Today, we are going to discuss about how you can automate your security operations center using Ansible. Now, I don't expect these numbers to be particularly telling at this point, but if we look at them in a sequence, they give a pretty good picture of the current enterprise security market. 103 billion is the total spending of enterprise companies in security, which includes hardware, software, and professional services. And this amount of money led to an average of 40 security solutions used by security teams, security operations centers, or both by CISOs. And with more money invested and many solutions in place, you would expect security teams to have reached an unprecedented level of efficiency. Unfortunately, most of them are able to process only 5% of the events or alerts generated by some of those 40 solutions we mentioned before. Although, if you're familiar with security, you know that 5% is not even that bad, especially if for the 5%, you're able to quickly assess the situation and immediately stop whatever needs to be stopped. Once again, this is not the case. Not only more than 50% of security teams report that the time to resolve an incident, a very important metric in security, has increased, but also that the impact of an attack landing successfully has increased significantly. So the situation of enterprise security is pretty bleak. But why is that? I'm sure you heard multiple times that the shortage of skilled professionals is the leading cause. But I'd like to challenge that. The problems in the security space can't be fixed simply throwing more people at them. First and foremost, there is an historical lack of integration between those 40 solutions we've mentioned multiple times. So imagine the amount of manual work that is needed for each investigation, just to jump from one tool to another. What also we have to keep in mind is that security is facing the same challenges as the rest of IT. The infrastructures security professionals defend are growing in scale, adding virtual machines to bare metal, containers to virtual machines, and eventually functions. And complexity, not only of the infrastructure layer, but of the applications hosted on top of it. Additionally, security has a unique challenge. In fact, cyber attackers have started employing technologies like artificial intelligence and automation in their attacks. This was theorized in 2017 and demonstrated by IBM Security in 2018, by the way. And this adds a component of speed to the equation. It's clear at this point that no human operator could cope with all of that without the support of technology, in this case, automation. We are in the classic situation where we want to fight fire with fire. And this wouldn't be the first time. If you have seen The Imitation Game, you should be able to tell what this picture is. This is Alan's Turing machine, the bomb. During the Second World War, Germans were encoding their messages using a machine called Enigma. Even if the British were able to capture these messages, no matter how good their mathematicians were or how long and hard the team was working, they couldn't break it manually. Enigma was recoded every day, so even if the team can decipher a coded message, the encryption key would be obsolete the next day, and the team was again left behind. Alan Turing had the intuition to use a machine to fight another machine, and he developed the bomb, which in the end managed to decipher Enigma successfully. And that's exactly what we are facing today with enterprise security. Research shows that automation, machine learning, artificial intelligence, and orchestration are the factors that could strengthen cyber resilience. Our machine in this case is the Ansible automation platform. Ansible has a proven track record in automating and orchestrating infrastructure, networks, and the application stack. And we recently decided to expand it to the security realm with an initiative called Ansible Security Automation. You see, the enterprise security challenges we discussed are all because we are not fast enough to respond to the security threats. And by not acting in a timely manner, we give the threats the chance to cause damage. We are not fast enough because there are so many different tools involved, each responsible for a different area of the enterprise security. When something happens, we need these tools to work together quickly, but with no integration between them, this is nearly impossible. Our answer to this lack of integration is Ansible Security Automation, an initiative to promote Ansible with its simplicity, flexibility, and ability to integrate as the lingua franca for security automation. The easy extensibility of Ansible enables you to bring together disparate things into a coherent whole, making it a perfect fit here. We have a broad library of modules, playbooks, and roles to support threat response. We currently have solutions to automate and orchestrate enterprise firewalls, intrusion detection and prevention systems, security incident and event management system, and privilege access management. And we are rapidly expanding to other areas. We announced security automation as a technical preview at Ansible Fest 2018, featuring Checkpoint as enterprise firewalls, North as intrusion detection and prevention system, and Splunk Enterprise Security as a CM. Splunk Enterprise Security at the time was only supported as a destination for the logs coming from other devices. Since then, we've been working with strategic security ISVs, either as technical partners, helping our engineers to build modules for their platforms, or active contributors, with the goal of provide co-support through the Certified Content Program. By the release of Ansible 2.9 and the Ansible Automation Platform 1.0, we had modules for Splunk Enterprise Security as an automation endpoint and IBM QRadar as a second SIEM. We had modules for Cisco Firepower and ASA, Fortinet Next Generation Firewall, and we are working with other partners in the enterprise firewall area. Checkpoint built and merged modules for their intrusion prevention system Blade, and starting with CyberArk, we are adding a whole new security domain. All this content is available through collections as upstream in Ansible Galaxy and as supported content via Automation Hub. But why have we started targeting these 4 areas in security? Enterprise firewalls and intrusion detection and prevention systems belong to the network security practice. This, on one hand, has a lot of synergy with our network automation solution. On the other, is a part of the basic security areas where, believe me or not, there is still a lot to do. Privilege access management is an extremely important area for our customers because many attacks and exploits target internal users, so being able to block a set of credentials or rotate a secret automatically is crucial to them. Last but not least, security information and event management are the most popular tools that security teams use to centralize investigation and their decision-making process. You may have noticed that security is becoming more and more prominent in many conversations and is reaching new heights like board meetings in large organizations. And this is because there are 2 major shifts which are affecting all of us. The first is that internet is changing and is becoming physical, I would say. IoT, for example, is giving the internet hands and feet, the ability to affect the world materially, and this changes the rules. So far, cybersecurity has been all about data, and for how vital data is, it doesn't hurt anybody. Now, we are talking about cars, medical devices, thermostats, you name it, all internet connected. And trust me, whoever you are, if you are in a self-driving car at 60 miles per hour, you care about security. The second shift is that both governments and private organizations acknowledge that security is not only an IT problem anymore. The process might be instigated by an IT problem, but the business impact has to be assessed and managed by the people who own that impact. So effectively, business process owner or product managers. Since governments are paying more attention now, things like GDPR in Europe and California Consumer Privacy Act in the US leads to the fact that we need the legal team to be involved. When and if it becomes a media thing, the PR may need to be involved. And people in the call center, for example, they need to deal with worried customers. So it's not about core practitioners anymore. Cybersecurity activities affects every department in the company, even who is not engaged in day-by-day security activities. Before moving to our customer story, I'd like to step back and talk about security operations centers, because not all of you may have been exposed to this kind of structure. A security operations center, or SOC, is an organization or a team usually operating 24/7 to prevent, detect, assess, and respond to cybersecurity events. All of that using a combination of clearly defined and repeatable processes and a combination of technologies and specialized skills. And SOCs aren't a new concept. Many large organizations had them for years, but as we said since the beginning, with cyber threat landscape changing so rapidly, threats getting distributed and complex in nature, our surface of vulnerability increasing, combined with a higher level of attention from both governments and customers, more organizations are working to implement or extend SOCs to obtain a better level of visibility and response for their infrastructures. And SOCs are implemented in different ways, depending on the unique characteristic of an organization, but for the sake of simplicity, we can group them in three categories. Fusion is the more, I would say, forward-looking model and not a common practice yet. And the idea behind it is to involve other functions within the company, as we described before, to have them working together. The command and multi-functions are the most common types of SOCs out there. Command SOCs are usually a group of highly specialized analysts acting as a governance facility. They monitor events and provide recommendations to teams outside of the security organization. The multifunction SOC is made of representatives of various areas of IT, working together to define and execute policies and actions. Keep this last one in mind, since it's the model we are going to see in our customer story. One last thing before we move to the customer. We have to keep in mind that introducing automation in a security operations center, or our security team in general, is a journey. And this is how this journey could look like. This is kind of a baby maturity model. And the message here is not that every organization must go through all the stages. The message is that you need to be able to assess yourself on this maturity model, looking at the scale of the infrastructure you want to automate and the complexity of the actions that you want to take. All of that to successfully introduce automation in your security organization. This helps to set the right expectations and adopt the right tools for the job. The customer we are about to start seeing was at the beginning in the first stage, where their goal was automating the response remediation tasks they were already doing manually, and is now moving to the second stage, where they started looking at security processes more holistically. The customer we would like to talk about is the Italian Army, Esercito Italiano. We have been working with the C4 command, which is responsible for the development, management, and security of the enterprise applications, systems, and network infrastructure. And you may be wondering at this point, okay, I'm not a government organization and definitely not a military organization. Why should I relate to this? And there are two good reasons for that. The first is merely quantitative, is a matter of sheer size of this organization. C4 Command is accountable for the mission-critical IT systems of the army of an entire country, with a population of over 60 million people. Their efforts aren't just limited to the national territory. They also support international missions. They have over 190,000 members of staff, including trained regular, reserve personnel, and civil servants. They manage around 470 barracks. Consider these as offices. And they manage these services across 15 data centers in various locations. And they also maintain their own extensive private network. The second reason why you should look at what they are doing is qualitative. There are some really valuable lessons we can learn from them. If we are to summarize those lessons into words, it would be readiness and awareness. Readiness is not a word you hear very often in the civilian world, And that's unfortunate because it's a key component for an effective response remediation practice. If you think about the military, in peacetime, they have nothing else to do but practice, a luxury that private organizations don't have, especially security organizations that live basically in constant war. One key component of readiness is rehearsal, but to rehearse something, you need to have a plan. When something happens, you don't want it to be the first time you are dealing with it. There is a saying in insurance, I believe, you can't predict tomorrow, but you can plan for it. What this means is that if the military decided that automation was the way to be prepared for a more efficient cyber response, we should probably listen to them. Awareness in the military can be summarized by one of the quotes that is up here from the former US Cyber Command commander. Every person that touches the systems in your company is an operator. Talking about awareness, this idea of planning in advance is being baked into a number of laws. Right now, being caught unaware is probably one of the less forgivable sins in the legal sense. What this means is the military believes that everyone in the organization who access the network, servers, any connected systems must be considered part of a response remediation process. So the fact that they chose Ansible as their automation platform means that they acknowledge its ability to be the universal language to open a conversation between security teams, network teams, IT operation teams, and so on. If you remember the three different types of SOC we mentioned earlier, this is an example of a multifunction SOC. The decision-making room is made of leaders from IT operations, networking, and security, and manages all the services delivered through Italian's Army 15 data centers, all the systems supporting the user endpoints, as well as maintain its extensive private network, EINet. At the moment, only the SOC has access to their CM platform, for example. As we mentioned earlier, SOCs are responsible for a number of things, including investigation, prevention, and response and remediation of cybersecurity incidents. The Italian Army started automating use cases in these three categories: investigation enrichment, threat hunting, incident response. And the Ansible automation platform helped them by not only accommodating real-world brownfield scenarios, but also helping automation to be adopted and security teams to become productive faster. Let's look very quickly at what they actually automated. IBM QRadar is their security information and event management system, or SIEM. It ingests information from multiple sources like users, database, systems, applications, network flows, etc., and uses the data to correlate against a set of rules to generate events or offenses meaningful for the security analysts. Redmine is a ticketing system that they use as a tracking tool, reporting all the actions taken as part of response remediation processes, and using this information for example, post-mortem analysis, performance analysis, and so on. They have two sets of enterprise firewalls, Cisco for the external network and Fortinet for their internal data centers. Fortinet is also their intrusion prevention system of choice in this case. Finally, Apache Syncope is their enterprise identity management system. When we talk about investigation enrichment, we are basically chasing pieces of information across the whole infrastructure to confirm that a certain event is or isn't a real threat. Ansible Security Automation enables the programmatic manipulation of logs. So for example, users can send edge firewalls log to log correlation or analysis facilities like a CM, or bump the verbosity level of the logs they already have, only when they need more information to assess an event as part of the investigation. Now, imagine that you have a mission in a foreign country. You have troops out there and you build a small data center to support local operations because they need access to the same applications and services as everybody else in the military organization. Now, this data center could be connected through a satellite link. The quality of this connection may not always be great, and the bandwidth is always precious. So you keep connected only the essential services and decide not to centralize all the security logs into your CM back at the headquarters. What happens if curator tells you that something suspicious is going on and the origin of that may be in that remote mission? If you look at the workflow, what Ansible can do is go to the remote firewalls and configure them to start sending the logs to the CM only when the investigation process requires that. And as part of the same workflow, Ansible tells the CM to accept this new information and parse that in the correct way. And once that is done, and you can close the investigation, through another Ansible playbook, you can roll back all the configurations to the previous state, since the business reasons to keep those devices disconnected are still valid. Obviously, if you look at the second and the last steps, you can track all these actions into Redmine, as well as part of the very same automated workflow. And this is an example of how one of the steps I described before could look like. This very short playbook is using one of the roles we built as part of the Ansible Security Automation Initiative. Roles are a great way to make workflow standardized and reusable to simplify actions that might be taken across similar tools but from different vendors. As you can see, what this playbook does is telling the firewall to forward log information to the CM. This is the exact same action, but instead of using a role, we are leveraging the vendor modules in our playbook. The reason why you may want to do that is because you have the need of using functionalities that are specific to a certain platform. In this case, vendor modules could allow a better level of granularity. If we look from the CM perspective, once we receive a new source of information, we need to be prepared to accept that. For IBM Curator, that implies creating a new log source. In this example, the log source is for a FortiGate firewall. As we said before, the use cases we are discussing are broad enough to accommodate real-world scenarios. An investigation enrichment activity may require to fetch information from many different sources. We saw firewalls before. Now the need is to collect information from servers. In this case, a Linux server. The workflow is very, very similar. Curator is always the source of the event, the triggering point, if you will. Redmine is the system used for tracking activities. What changes is that Ansible is now used to connect a server and search for a set of parameters, a string, or a certain file. The result of this activity may or may not confirm that a real threat is happening. Like we saw before, this is an example of how one of those actions looks like. As you can see, thanks to the YAML language, Ansible playbooks are basically human readable and very simple to create and maintain. If we look at threat hunting, which is a prevention activity where security analysts update their tools to identify newly released cyber attacks or malwares, the modules part of the Ansible Security Automation Initiative support, for example, signature manipulation to load and create new signature on intrusion detection and prevention systems, support the manipulation of correlation searches and event automation on a CM, so analysts can create new alerts from actions or changes operated on other security devices. On a regular basis, the C4 command gets security bulletins from various sources, such as the European Union, the Intermilitary Cyber Command, and security ISVs. These bulletins contain updates of the signatures for the latest attacks, new compromised domains, IP addresses, nearly everything. They come in various shapes and forms, but ultimately they all end up in a spreadsheet. The use case described in this slide supports the team in charge of managing and maintaining the Curator custom rules engine and responsible for the offense generation. The information in that spreadsheet needs to go in different places. And one of them is, of course, the Curator's custom rule engine. Doing this manually involves a lot of tedious and error-prone effort. a lot of point and clicks. With Ansible, the data from the spreadsheet could be ingested and used as an external source for variables for different playbooks, like one that can automatically update a rule in QRadar. Now, the process is bulletin received, ticket opened, playbook executed, and the rules and therefore offense generations are updated. As we said multiple times at this point, these activities involve many different platforms. So let's have a look from the point of view of the intrusion prevention system administrator, having to perform the same update process. Fortinet is one of the platforms certified as part of the Ansible Security Automation Initiative. And through these modules, Ansible can be used to automatically implement new signatures starting from the very same security bulletin we described before. Once again, this is an example of how the task of implementing a new signature would look like. In this case, we are directly using the vendor modules that give us a higher degree of granularity. Last but not least, we can look at what we can do for incident response. In this context, Ansible can help you to automate all those actions that will actively stop a malicious activity. The workflow here is pretty straightforward. The CM generates an offense and flags an IP address. A tracking ticket is automatically generated. And since the CM already flagged the IP, the operator knows it needs to be blocked. Now, in a pre-Ansible world, what would need to be done at this point is logging into all the edge firewalls and update each one of them individually. They may have different versions of the software on board, maybe from different vendors. Some of them may require a telnet connection, some SSH, and so on. But through a set of pre-approved Ansible playbooks, the operator can, with a single action, immediately remediate, blocking that IP address and protecting the Army's network. Back to QRadar, if the attack is no longer happening, they successfully executed an end-to-end automated remediation. And this is another example of this remediation task, how it could look like. In this example, we are leveraging a role, and this is why the playbook is very, very simple. Once again, roles are a great way to make automated workflows reusable across multiple platforms. This is yet another example of how each one of these use cases goes across multiple technologies in different domains. The flow is very similar to what we saw before. The CM is the triggering point, generating an offense that, in this case, tells the security analysts that a set of credentials may be misused. Redmine is always engaged in a tracking capacity, but what is interesting here is the addition of a first step that effectively quarantines the credentials while the investigation is done. This is an example of how, depending on the perimeter you are touching with your security processes, you may make different decisions. Since the impact is potential on a single user, with a risk analysis exercise, we decide that it is more beneficial to block these credentials while we decide if there is a problem or not. In this way, we can immediately block any potential unwanted access while the disruption in operations have a small impact. If the investigation determines that everything is fine, the user can be released, so to speak. Otherwise, a password reset will be forced. And this is how the quarantine task looks like once translated into an Ansible playbook. So far, you've seen snippets of automation. The truth is that in the real world, they tend to be tied together in more complex workflows. Here we have a tower workflow expression of the process outlined in the previous slide. This shows each step being automated with information passing between stages of the workflow and the remediation task to take if the automation is not successful, which will properly alert the SecOps team with information about the issue, so it may trigger further triage. If you remember the maturity model we started with, this is how it looks like from the perspective of Ansible. The Italian army started on stage 1, building a set of Ansible playbooks to automate many of the tasks they were performing manually, saving time and reducing human error. They are now moving to stage 2, when these tasks will be collected in a larger and more complex workflows and distributed to the 24/7 response teams across the organization. This will allow the decentralization of part of the response operations while ensuring the consistency of the action taken and more visibility into the infrastructure. I hope this was interesting for all of you. And once again, if you have to take away a single thing from this session, look at this maturity model, assess yourself on it, and make sure to set the right goals for your security automation initiative. We are sure Ansible will be able to help you with that. Hello, everyone. My name